Okay, we're going to talk about writing linear equations from a table. How do you write an equation to model a linear relationship given a table? Remember, we need to be reading the story and seeing what's going on, and the table is going to be seen as an extra way for us to look at the data that's given to us by the story. So here we have in this example, the Lopez family uses maple syrup sap from a tree in their yard to make maple syrup. It actually tastes pretty good. The table below shows the temperature of the sap as it heats. So here we have a table, and it shows our time in hours and our temperature in Fahrenheit. So what we have to do when we're going to start to look at this table and to write an equation, we need to first start out by defining our variables, the dependent variable and the independent variable. We know that the independent variable is x, and the dependent variable is y. When we look at this story, we know that the temperature, how hot it gets, depends on how long it's going to sit on top of the stove and get hot. So our y is going to be our temperature, and that's in degrees Fahrenheit. And this is going to be our time in hours. Now we know also what's really cool about a table is that it automatically kind of puts it in our independent and dependent order. Always the x values will be on top of the table and the y values will be on the bottom of the table. Okay, so once we figure that part out, our next step is to graph our data. So we're going to take a look at these points, 0, 38, 183, 2, 128, 3, 173, and 4, 218, and we're going to put them on our graph. We're going to notice that our graph, we are going to take a look at the different what's worth, each one's worth 25. So each point is worth 25, so we want to make sure we put them in the right place. So we have 0, 38, so that's going to be right there between 25 and 50. We have 183, which will be above 75, but before 100. 2 and 128, so just a little bit above 125. 3 and 173, so just a little below 175. And 4 and 218, so probably somewhere in the middle. Now when we look at this, we can also remember that we can draw a line through our data because there's going to be obviously increments in between that aren't necessarily going to be 1 hour, it could be a half hour, things like that. So what we're going to do is we're going to draw our line from this point out. And that way we can see parts of hours as we look at data. So the next thing we're going to do is we're going to find the slope. In other words, we're going to find the angle of this line. Now we can't do rise over run and pick 2 points on the line because the points are not crossing smack in the middle of corners to make it easy for us. So what we're going to do is we're going to use these points that are given to us here. We're going to use 0, 38 and 1 and 83 and do the slope formula. So y minus y divided by x minus x. We're going to take those y values and we're going to use 83. We're going to use that point first because that way we can keep our number positive and not deal with negatives. And then we're going to subtract the other point, so 38 and 0. 83 take away 38 is 45, and 1 take away 0 is 1. We have to remember that every number represents a situation. So for us, this 45 over 1 means that it's going to be 45 degrees Fahrenheit every time 1 hour goes by. So that way it tells us. So it's as the sap is sitting on a stove, as it's getting hotter, every hour that's going by, that temperature is going to climb by 45 degrees Fahrenheit. The next thing we're going to do is decide whether it's proportional or not proportional. Well, there are some clues that will help us to figure out if things are proportional or not proportional. First of all, when we look at the graph, it's not going through 0. So that's right away telling us it's not proportional. We can see it in the table as well. Remember, where x equals 0, that's going to be where the y-intercept is, and we can see it's 38. So we can tell by the table as well. So we can tell by the graph, we can tell by the table, we can also tell by the story as well. Because they're taking this tree from their yard, this sap from the tree in their yard, and then before they put it onto the stove itself before it starts cooking, it's going to be at room temperature. Well, room temperature we know to be greater than 0, so we know that it's not going to start at 0, 0 because the temperature in the room is never 0 degrees. It would be pretty darn cold. In fact, that's less than freezing. So we know then it's not proportional. The next thing we need to do then is to find our y-intercept. So we can do this by looking at the graph. We can see where it's crossing. Again, from our table, we find out that b is 38, the y-intercept. Then the last thing we do is write an equation based on this information, and we know that our equation is y equals mx plus b, where m is the slope and b is the y-intercept. So all we have to do is replace the m and the b with the numbers we just found. So y equals 45x plus 38. And remember, every number tells a story. So what this equation is telling us, if I only knew about the Lopez family, this one sentence, the Lopez family uses maple syrup sap from a tree in their yard to make maple syrup, I would be able to look at this equation and say, well, when they put the sap on the stove, it was at 38 degrees Fahrenheit, and for every hour that it's going to be on the stove, it's going to climb 45 degrees for every hour that goes by. So remember, this is going to help tell the story. We're going to do one more problem, and here we're going to talk about Joe. And Joe made an initial deposit to a bank account and then added a fixed amount each week. The table is going to show the money in his account, and we're going to write an equation to represent the situation. Now, before I even look at the table, I already know if something is proportional or not proportional, because he goes and puts an initial deposit in. Well, if he's going to deposit money when he first starts his account and no time goes by, we already know it's not proportional. So let's start going through our steps once again, and we're going to define our variables. So we know that x is the number of weeks, and y is going to be the balance in the account. And that's going to represent money. Okay, our next step, we're going to find the slope. So again, we're going to use 2 points. So we're going to use this point 1, 140, and 2, 160. And we are going to find that slope. So remember, y minus y, take away x minus x. And once again, I'm going to use this second point as the first numbers that I'm going to use so I don't end up with negatives. 160 minus 140 is 20, and 2 minus 1 is 1. So again, what does 20 over 1 mean? Well, it means that $20 is going to go into the account every week. So now that we found the slope of the line and what it means, and we've already talked about whether it's proportional or not proportional, so we know that it is not proportional because there's an initial deposit, we're going to go and find the y-intercept. Now, we could do it by the table, but I'm going to show you the long way because we've been practicing that, so I want to make sure everybody knows how to do it because it works all the time. We take our equation, y equals mx plus b, and we're going to replace in the y, in the m, and the x what we know so we can find the b, the y-intercept. I'm going to use this point here as my x and y. In the y place, I'm going to put 140. In the m place, I'm going to find that 20, which we just found is our slope. And in the x place, I'm going to put that x value of 1. So I have 140 equals 20 plus b. So I have to think to myself, 20 plus what will give me 140? And hopefully everybody realizes that that's 120. So now that I have that, let's go back to our table before we go to this last step, which is to write an equation. Before we get to that, I do want to show you something on the table. We can look at the table and actually find the slope. The slope, remember, is the rise and the run. We can see the run is changing by 1 each time. And in the table, this is changing by 20 each time. So if we know that the slope is the change in the y over the change in the x, we know that this would be 20 over 1 because we can see it on the table. We could also find the y-intercept from the table because we know if we go down one more time, it would go to 0. And wherever x is 0, that's where the y-intercept is. And if this goes down by 20, we're going to get 120. So that just proves our point of what's going on. So once again, we're going to write an equation, y equals mx plus b. And we're going to take our values for the slope and the y-intercept that we just found over here, which is 20 and 120. And we're going to write ourselves an equation. So we're going to write y equals 20x plus 120. And again, how does this tell the story? What's going on? Well, Joe made an initial deposit of $120 when he went to the bank. And then every week he added $20 more. So hopefully this explains how to write an equation from a table and also from a description.